Hello everyone, how's everybody doing? Hope you're doing better than me. Just woke up from a nap a little while ago. Got my face a little bit puffed up, my nose a little congested because I'm sleeping face down on the bed, and that does that. Until I get my face back, it takes a little while for that to happen. Someone here pointed out the other day concerning my thing, my the pain in my back. Okay, and two of them put comments there. One guy said, maybe I should sleep on my side. I tried that the other day, I think 2 days ago, and big problems. Three times I was woken up by very sharp pain. It's extreme pain. It's like someone stabbing you, putting a knife through your back. It's very painful. And, sometimes I don't know if it's you got a pinched nerve, something with the sciatic nerve, or it's just a muscular pain. I still don't know. I got to wait a little while to find out. Another fellow says, seeing our vertebra, automated electroacupuncture for your back. Yeah, I've got something that gives me heat in the back, in my back. This one is a vibrator of some kind, electrical vibrator, gives you massages. And the issue there is like acupuncture. It works like acupuncture. Having these pins put in your back. And a few years back, quite a few years back, um, uh, I looked at acupuncture. I always had this fascination with acupuncture, whether it really worked or not, and I thought it was very rational. Your whole body is interconnected. You have what they call these meridians, so they pinch here and you feel it there, that sort of thing, so that they can manipulate the pain in such a way where they can either increase the so-called energy in a certain region or take away from that energy, and that way they can um, manipulate pain. And one day I went to a Chinese fair, and I saw something like this, and there's several of these running around. This is just an example. The guy being operated, and he's only being anesthetized with acupuncture, or so they say, and he's got open heart surgery. Now, if that doesn't convince you of acupuncture, I guess nothing will, right? And I still have my doubts. I went to acupuncture about maybe 2 or 3 years ago. I think a little more, maybe. I tried it for the first time in my life, and I went to 10 sessions for arthritis pain. And I'm going to be honest, it didn't do anything for me. Okay. Now, some people say, well, you got to go to a guy who's certified, someone who knows. This lady who did the acupuncture, she put the pins wherever she had to put them. It didn't do anything at all whatsoever for me. So right now, I'm a little skeptical about acupuncture, exactly what it can do, what it can't. It just seems rational to me, the fact that, our bodies are completely interconnected. You pinch your toe and you feel it in your brain. Your brain immediately receives that signal and tells you, hey, pain, alert, alert, emergency, So the jury is still out as far as I'm concerned. I'd have to look at it in a lot more detail to really figure out if acupuncture has any merit or not. What I will tell you is something that might have to do a little bit with what we're going to talk today, and that's this synapse. Okay, and our bodies are connected completely from head to toe with neurons. We have neurons in our brains, etc., everywhere, and these are our nerve system, right? And they work electrically and chemically, and possibly magnetically as well, somewhere, So we have electrochemical and magnetic working in there. And they'll show you this. They'll show you two neurons, and they have that region called the synaptic cleft. It's a no man's land region, okay? And they don't know what's going on in there because it's invisible. There's just separation between neurons, but somehow one neuron communicates with the other. and that's a good place to put the rope model. Okay, and this is what how I see what is happening in that region. There could be a chemical reaction. That means that atoms, molecules are moving, right? And this is the electrical version here. You can see it there. If there is electricity going on between two neurons, this is more or less what it would look like under the rope model. In other words, you would have a string of pearls there, what we call a serpentine. They're going to be moving in a certain direction, and whichever way they move, that's what we call electricity. And what's moving orthogonally to that are the threads that are swinging around, and we call that whole thing, invisible thing, we call it a magnetic field. Okay, so I think that would look something like that. This would, let's see, hold it if I can get this thing in here. This would probably, let's see, I lost it. Give me a second here. I lost one that I was going to put up here. Here it is. Sometimes they get stuck. This would more or less, this is what probably these things look like in real life. You can see there's an electrical impulse going through that channel. And what I'm saying is, you know, this is what you would see. That's like a wire. And this is what you would see inside the wire. Okay. So under the rope model, this is how you would see the connections throughout your body if you had God's eyes, right? And all I can say is, you know, this would be the model according to the rope hypothesis, okay? And so, I'm saying, yeah, the body is interconnected. The molecules form these cells known as neurons, okay? Not only for the brain, but for the rest of the body. They're specialized neurons, right? And I think they're interconnected by this region called synapse, which nobody knows what's in there because it's invisible. There's a gap between neurons, and we either fill that with spirits, okay, or we fill it with electricity or chemicals. Now, chemicals we might be able to detect because, you know, we've got maybe flow of molecules, reactions that we might be able to detect, and I think they've done that. But then the question is, now we have electricity. How do you detect electricity? And that's why they can't. They can't detect it because electricity, like magnetism, is invisible, whatever it is. It's just at a different level. And what I'm saying is, if the rope model has any merit, this is how I think it would look. You know, you would have these serpentines twirling from one neuron to the other. So there is a physical connection lined with these aligned atoms, and they're all spinning in the same direction. And in an orthogonal manner, perpendicular, right? We would have the so-called magnetic field, which is just a sweeping of countless threads. Okay, so I think that's why we can't see them. It's just like a magnet. You can't see the threads between a magnet, but hopefully you don't put spirits between two magnets. There's something going on there, and that something, what do we call something? That which has shape. And that which has shape is spinning at great speeds, right? And it creates this region, which we call a magnetic field, for lack of a better term. So that's a term that we've been using now since the days of Faraday. Faraday is the first guy who put that word in our mouths, field, okay? Okay, there was a comment. Fellow put a comment, unrelated, but comment nevertheless. And he says, you don't believe in Neanderthal DNA in humans because it doesn't fit in the rational science. Well, it's not that I don't believe. This is not an issue of belief. So let's put it in the right context. Here's my answer, okay? Yeah, in science, we don't believe, okay? Belief is religion, opinion. In science, we make assumptions. We make an assumptions, okay? And for example, I make an assumption. I say, which we call a hypothesis. Say modern humans have approximately 2% nuclear DNA in common with the Neanderthals. I do concede that. I think that's what's been shown in the lab. Okay, and we're talking about nuclear DNA. We have no mitochondrial DNA from Neanderthals, which means, you know, none of their females passed any mitochondrial DNA to our species, okay, which is strange. And then if I concede that hypothesis, if I start my presentation and say, look, we have 2% nuclear DNA in common with the Neanderthals, then you have to go to a theory, which would be why? Why do we have that? And the answer I give is not that we had sex with the Neanderthals, but that we separated from them, Neanderthals and Cro-Magnons, you could say, the people who eventually entered Europe. We separated from their lineage maybe anywhere from 500,000 to 1 million years ago. So we separated a long, long time ago from the Neanderthals. And this also takes us back to whether we can even mate. I mean, we've had this long separation. And that's one issue. But the other issue, probably more important, is that they developed in Arctic Europe. And we developed, as far as I'm concerned, in Africa. Okay, that's what I concede. That's how I start my presentation. That's what, after reading many papers, that's my conclusion. Okay, so that's my foundation. Other people might have other foundation. You have religious people out there who don't believe Neanderthals ever happened and ever existed. So, okay, everyone starts his presentation the way he thinks it should be started, and that's the way I started. And so we have this long separation. The Neanderthals evolved in Arctic weather. We evolved in sunny Africa, okay? And when we went there, we had clothes. They did not need it. We must have been very different to them. They looked very different to us. The way I picture them is as gorillas, right? So that's my foundation. And I have that foundation based on, I pointed out a map the other day where we have some kind of hominid living in England, right? Near London, there was a region there, and apparently they lived, some kind of human-like creature lived as far back as maybe 800,000 years ago. And I think the Neanderthals developed from that creature. And that had to be probably Homo erectus or Homo antecessor. It's got to be one of those. Homo heidelbergensis comes a little later, and then Neanderthal comes later. And so we have to believe that there was an evolution from this early humanoid, right, all the way to Neanderthal. There had to be some kind of evolution. And those are my foundations. Those are the ones that I usually start. That's how I see the picture, okay? And you don't have to accept it. You can have your own foundation, and that's it. You build upon what you've read, and the best way always to stand behind it is by producing, where did you get that information? What did you read? Show me some references. And yeah, those references can be criticized. That's part of the scientific debate, okay? Nothing you can do about that. People have different visions of how this universe works and what really happened in the past, okay? So yeah. Anyways, person also asks, you think love is a concept? Yeah, I think it is a concept. And one of the issues you could answer this is with the joke that I heard from the Three Stooges for the first time. And Mo asks Larry, he says, "Can you fix this?" And Larry says, Mo says, do you think you can fix this? And Larry says, "I don't think, I know." And Mo says, "Well, I don't think you know either, but go and give it a try." Slaps him on the head. And so I can't say, well, I don't think I know, because I might get bitten in my butt, right? But this is my answer, okay? In science, we don't think, we don't believe. Science, we define. We have to define the word concept. What is a concept? Something no one has ever done. No one has defined it scientifically. Here you have a scientific definition, whether you like it or not. I mean, you might have a different definition. Fine, put it forth. I want to see it. Let's compare notes. This is my definition: a word that invokes or embodies two objects or two words treated as objects, okay? So all words that embody motion are dynamic concepts. And then you have some dynamic concepts. And one rule in physics is you don't move concepts, you don't transfer energy or information, you don't move a mass, you don't extend the field or whatever. So, we can't use these words as physical objects, not to give a physical interpretation, okay? So under this definition, love is definitely a dynamic concept. And if you look up the word love, and I'm not going to go with any definition of mine because, I don't care about this word. It's not important for physics, so I don't deal with it at all. But these are the definitions you find in the dictionary. The first three, one says passionate affection for another person, a feeling of blah, 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 and sexual passion. Now, those are all dynamic concepts. So yeah, love is a concept according to the definition that I've got up there. Anything that's got motion has two or more locations of an object. That means you have several frames in the movie. And so what you're doing is comparing one frame in the movie against another frame in the movie. Okay, you're treating these two as separate objects, as if, just because they're at different locations. And so, yeah, any motion, jumping kangaroo, running boy, those are all concepts, dynamic concepts. You don't have a static object. The only way to present an object for the purposes of physics is you look at it as if it were the only object in the universe. Okay, so that means you have the backdrop, which is space, which is nothing. Okay, that's the backdrop, and you have the table there. And you point, you say table. And now the ET understands your language, okay, because he knows what the word table means. That's the way you present an object in physics. And you can't do that with energy, you can't do that with field, you can't do that with mass, and you can't do it with love. I can't point to love. What am I going to point to, a heart? So yeah, love is a concept. And again, every word in the dictionary, it's either an object or a concept. There is no third category. Okay, and so if you have problems with that, there's only one remedy, one aspirin that you can take, and that's put forth your definitions for object, which we need for the purposes of physics. You can't do physics without an object. And put forth your definition for concept. And then we'll know whether love is a concept or not. And of course, you got to defend that definition with shield and sword, okay? Because I'm going to do my best to attack it, okay, to destroy it. And that's the purpose of scientific debate, to compare notes, okay? Okay, another comment, final one today, okay, so I can get to the matter at hand, which is Mr. Michio Kaku, okay. It says, how do you verify that the prehistory you are using is correct? It is difficult to question what we were taught in childhood as being incorrect. Absolutely true, absolutely correct. Yeah. What if some of the prehistory you have been taught is wrong? Okay, how do you verify it or trust it? You cannot use peer-reviewed science papers as being truth of anything. Totally agree there. We're on the same page. I find it interesting that as a rational scientist, you don't question all of prehistory. There are many clues it may not be correct. Very good comment, all of it. Love it. I think I addressed it sometime in the past. Just in case, I'm going to rehash it right now. Once again, I want to make sure this issue is taken care of. I think it's an excellent comment, okay, and I think people should be aware, what kind of answers do you give to a fellow who brings this subject up, this issue up. Okay, here's my answer, okay? Okay, and so let's go slowly through it. In science, we don't verify anything, okay? So we don't verify or prove, because verification, proving, is to yourself. You are trying to convince yourself, you are trying to persuade and recruit yourself to a certain way of thinking. In science, we make assumptions. Again, we call it a hypothesis, okay? A scientific theory explanation, and that's what a theory is, begins by visualizing the initial scene. And that's known as a hypothesis. And so we make an assumption. We say, let us assume that Napoleon fought at Waterloo in 1815. Okay? And the theory will be, Napoleon went to Waterloo because, and then you fill in the blanks. You say, well, he went to Waterloo because of this or that reason. Okay? Now, did I ever see Napoleon? Did I ever shake hands with him? Did anyone alive today ever see, hear, touch Napoleon? And you might say, well, I've seen a picture in France of Napoleon, or, I read this historian who talked about Napoleon. He got it from another historian who got it from another historian. We have no way of proving the existence of Napoleon or that he ever was. Does this mean we cannot theorize about Napoleon? And if I cannot theorize about Napoleon, much less can I about the Neanderthals. Okay, I mean, these guys, died out, if what the record appears to show, 40,000 years ago, which is when the Mousterian technology disappeared. I cannot talk about the Neanderthals because I never met one. I never shook hands with one. Well, this is as close as I ever got to a Neanderthal. Okay, here I'll show you. Okay, I was in 2015 at the Mettmann Museum, also known as the Neanderthal Museum up north here in Germany. And on the right-hand side, you'll see, that's a Neanderthal skull put on a body. Okay, so that's the closest I ever got to a Neanderthal. And the question is, I've never held a Neanderthal skull in my hands. I never was able to look at it in great detail or compare it against the Cro-Magnon skull. Probably would not even know what to look for. I mean, people who have done this for a long time, studied it, they probably would know what features to look for. All I would be able to say is, well, they're different, obviously. And I might see, well, they've got the brows, maybe my nose, like, I've got a Neanderthal nose, okay? And no chin. I might be able to see some of those features because I'm familiar with them now after reading some stuff out there. But I've never held a Neanderthal skull in my hand. Does that mean I cannot theorize about the Neanderthals? Stephen Hawking, he never saw a black hole. He theorized about black holes all his life. And so the question is, do we need that big word there? Do we need to observe in order to do science? And the answer is no, I don't need to observe to do science. I need to read and read lots of paper. I can't read every paper that was written of every subject on planet Earth. There's got to be gazillions of them. And so that means, I can't talk about that subject because, I read about it, but I have not touched it. I have not seen it. I have not smelled it personally. People have the wrong idea that this word observation, to make an observation, that's part of science. It's not. If science is what it says down there, rational explanations, I just need to explain. I don't need to observe. I don't need to run an experiment. I don't need to measure, calculate. Those are all descriptions. I don't need to describe. I'm not here to describe. I'm here to explain. I'm going to explain a mechanism, especially as it relates to physics. What I want to do is explain a mechanism, how, for example, Mother Nature does gravity or does magnetism. That's what I want to explain. Do I need to observe, see electricity and say, now I can see, I've got proof because I observed electricity running in front of my eyes. So now I know exactly what electricity is. I mean, if we could do that, we would say, if we could all see electricity, we could say, it's the flow of bullets, because I've seen them running from one place to another. And we don't have that. And so we have two versions today. One is the official version out there, and the other one is the one that I'm proposing, which is the torsion of, or the twisting, the torquing of a long line of merged electron shells. You have to have atoms there. And you might say, Bill, did you observe that? Did you really see it? Did you touch it? Well, I worked with electricity for a long time, where I worked in the semiconductor industry, and I had to work with electricity, vacuum especially. One of the things you notice with vacuum, if you take the vacuum way high, like, you take it to the -7, -8 torr, well, you got less and less material in there, and at some point you can't run a current. And you say, well, hold it. It's not completely empty. There's still atoms in there. Why don't we have, electricity flowing? Well, we have, if If electricity is the flow of electron bullets from cathode to anode, right? Well, even if I don't see them, it should be, I should be able to shoot bullets. If it's a gun shooting bullets, I should be able to get a current, even if I don't see it, when I remove all the matter. In fact, I should get more bullets because now the mean free path has increased. The bullet has nothing to bounce against, nothing to stop it. So we should have more current when we evacuate the chamber. And it's the other way around. You need to have atoms in there to conduct electricity. And so the classical version, because that's the quantum version, the flow of electron bullets, which is nonsense. The classical version says, well, yeah, we have to have atoms, and what the electron does is go from one atom to another, like beep, 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 occupying the valence level in a long line. Well, that's a little more rational, because then if you remove atoms, then the little electron ball has no spot to occupy the next step. So that's a little more rational. And my version, again, is the twirling of merged electron shells. And so, we don't see it. We can't see it. All you can do is theorize about it and say, what is the mechanism? Okay, so no, observation is not part of the scientific method. Okay, should not be. Okay, because people introduce their personal opinions. We don't have witnesses. All you can do is read papers where people analyzed, reach your own conclusions, and then present it as foundation. Now, every time I speak about the Neanderthals, I'm not going to say, let us assume the Neanderthals existed, or that there were Neanderthals around. You can't do it. It's taken for granted that that's what I'm saying. That's why I'm saying, we have atheists, theists, and agnostics. They've been running around in circles for ages, and they're all retarded, all three of them, because they're fighting, well, does God exist? Well, no, God maybe doesn't exist. And this guy said, yeah, I have proof that God exists because, see, there's this perfect flower, and then you have the birds and the bees and Adam and Eve. And the other guy says, no, but look at all the crime that's in the world. Why is there so much evil? It looks like the devil is stronger than God. And they go through all this argument, and they never define the word exist. So all we need to do is define the word exist. We'll know if God exists or not. We don't have to debate whether God exists or not. All we have to do is follow the definition. Say, well, if the definition of the word exists is physical presence, you need physical, an object, you need presence, you need location, an object that has location. Well, if God wants to exist, he's got to be an object first. He can't be a concept, first of all. And second, he better have location, meaning there's got to be a distance between my chest and God's chest. Then by definition, God exists. We don't have to worry about, personal opinions of whether you observed God, in the toilet or wherever. You don't see God. You can only make an assumption about God, and the assumption has to include the definition of exist. Then you can say, according to my definition, God exists or doesn't exist. We're done. It's a question of definition, not a question of belief, and not a question of observing. Okay, so observation is not part of the scientific method. A blind man can be a scientist, a physicist. Okay, he doesn't have to observe. Someone brings a problem to the blind man and says, they say Homer was a blind man. Okay, so we go to Homer and we say, hey, Homer, how do you explain gravity? And so you say, this is what gravity is. So, without observing anything, Homer can just say, well, things come down because they're all physically interconnected. Okay, so now he's got an explanation of gravity. He doesn't have to observe anything. Okay, he doesn't have to observe black holes or Neanderthals. Okay, let's get on with Michio. Good old Michio. The other day I started with Michio and I said that he's a theoretical physicist, a futurist, a popularizer of science, and I presented him as an astrologer, right? But really, my version of Michio is a little different. He looks more like this. I think he's a caricature of physics, a caricature of science. He's not even a character, he's a caricature. Okay, and why do I think that? Well, because this is what he does. He's like all the other celebrities of physics. They no longer do physics. What they do is irrational philosophy. And every explanation that they put forth is not even supernatural. It's irrational. It's surrealistic. You cannot even imagine it. Okay? And since these guys get bored of that, there's no money in physics. They move on and they say, look, if I'm going to have a show and talk to people, people want to be entertained. They don't want to be educated. And so they start analyzing, like in his case, the mind, the relationship of your way of thinking to QM, why you think like you think because of the physics of QM, of all the things that we have proven, such as, the uncertainty principle, the fact that a particle has, the more you know about its momentum, the less you know about its location, its position, as they call it, okay? And then you affect it by just staring at it. It's like, particles have this sense of knowledge that they know they're being spotted and they know they're nude, they're, completely disrobed, and they don't like you to look at them, so they move around. They say, well, when you look at it, you're throwing photons at it, you're moving it. So you can't really see a particle in its when you're not looking at it, it's okay. But when you look at it, you're disturbing it. You're perturbing its state, its static state. That's what they say. And so they include the mind into that. They start talking about the mind like we're going to explain the mind, how you think and why you think the way you think on the basis of QM. And then they move on to recommending how to live. They talk about the future. They predict, they all predict the future. They love that word predict because the word prediction has always been associated with knowledge. If you can predict there's going to be an eclipse tomorrow, it's because you know, okay? And so they get into all this other stuff like Michio does. He specializes in all this stuff, telekinesis, mass effect, black hole, and dark matter, okay? And I got to say a little bit about that dark matter thingy that he mentioned. And let's go through this little by little so we can see, because, they talk about dark matter and the string theorist, and Michio Kaku is a guy who does strings. And so they say that this dark matter, it's invisible, but it's particles, right? It's always particles. But each one of those particles is a vibrating string. So whether you talk about dark energy or dark matter, it's a vibrating string in that background there that we can't see, that we can't feel. Ultra heavy, right? It doesn't, I don't know, it doesn't squash me. They say it's all around us. And I don't know, it's so heavy and it's all around us, but I don't feel that it's crushing me for some reason. But then out there, they have to explain certain things like, the galaxy rotation problem, which I'll go over in a second here. And in order to explain that, they have to introduce dark matter. Why? Because dark matter stands for mass, for kilograms. And have you ever seen a kilogram? Well, no, and that's why we can't see them, because you can't see a kilogram, especially if it's dark. It's a dark kilogram, and they call that dark kilogram dark matter. So they put as much matter wherever they need it around the galaxy to make it do what we observe. So the astronomer goes out there, he looks, he says, look, this is what we're seeing, the speed of stars. This is how the galaxy is rotating. We don't know why the stars don't fly out of that carousel. And so the mathematician says, oh, I know why. I can explain. Okay, why? And he says, well, see, if you sprinkle dark matter here and there, dark kilograms, you put all these kilograms wherever you need them, well, then you can have this cohesion. You can have this whole bundle of stars, gazillions of stars twirling in a circle. None of them fly out. Okay, so let's look at a galaxy. Here we have the Andromeda galaxy. Some of you might have seen it. It's a beautiful thing, beautiful picture there, okay? And let's turn it sideways. Got to go slowly here because I got a lot of these here. Let's turn it somewhat sideways, and we're going to flatten it out and turn it a little bit sideways. And now let's put it horizontally, okay? So there we're seeing the galaxy from the side, okay? That's what we have in front of us. Now, the mathemagicians, they'll tell you that it's got a black hole in the center. They say all galaxies actually have a black hole in the center, for otherwise they wouldn't be able to justify certain things that are happening near the center of galaxies. Okay, what does it have on the edges? Well, you got to put dark matter in there. Why? Because in order to for the stars on the outside to go as fast or faster than those on the inside, there's only one way they can think about, and that's by putting dark matter, dark kilograms in that region. Okay, and this is what they have to explain. This is the problem. The problem is this is the chart of what's happening to the stars. The farther a star is from the center of the galaxy, the faster it goes. And you say, how can that be? I mean, Pluto goes around the sun and goes much slower than Mercury, which is tied to the sun. And that's what they thought a galaxy should look like, and that's absolutely not what a galaxy looks like. A galaxy has this shape where you have the expected, what you calculate should be, and instead you have that upper graph there, the line there, that shows that stars are increasing in speed on the outside. How do you explain this? Well, the way they do it is they put mass in there. They put all these dark kilograms. Those K's stand for kilograms, and it's got to be more kilograms the farther out you go. So this is how our galaxy is constructed, with these dark kilograms. And of course, they're conveniently invisible, and I don't know how they justify that. They just simply say, we can't see it, but we ask the astronomers to look for it, with their telescopes, see if they can see something out there. Okay, so what is the problem with this? Well, let's circle 5 stars over here, okay? Let's circle these 5 stars in one region on the outside of the galaxy. Let's look at that. Remember, we have dark matter in that same region, and that's why you have to put that dark matter, those dark kilograms, in that region in order for those stars, first, not to fly out, okay? And second, to create that speed that they need. They need more mass out there. Okay, and so they put these things that they can't see, and they say, well, there's dark matter in there, and they've always proven it. Okay, and so dark matter is proven. It's beyond belief now. Now they're in the proof region. Okay, here we have our 5 stars, and they look like the sun, so I just put 5 suns in there, and they're very distant from the center of the galaxy where you have the black hole, and in between that, you got to put dark matter. Okay, you got to have dark matter in there to create the effect that the astronomers are observing, that they're seeing out there, okay? And so what is this dark matter? Well, according to general relativity, because that's where they start, okay, it creates a depression. It looks something like that, okay? So wherever you have dark matter, it's heavier than whatever is next to it, whatever matter, real matter is there, and matter should fall into the hole. We should have all these depressions anywhere close to dark matter, because that's gravity according to general relativity. That's out there in space, right? The macro picture. And here we had Mr. Brian Greene, and he showed us that depression. He says, look, when you have a lot of mass, it pushes space-time downwards, and then you have matter rolling around it. Okay, so that is the explanation, the physical interpretation of gravity according to general relativity. Okay, so what happens next? Well, okay, so let's put these fishnets there next to these suns, these stars. Okay, we're going to put these fishnets there. Okay, and what should we observe, or how are we going to explain this according to general relativity? Okay, well, the way I picture it, it looks something like this. Okay, these stars should travel around in circles, because they have all these depressions, all these little roulettes there, and they're little balls that are rolling around all this dark matter that's all around them. Okay, we should have depressions. And you can see that this is a little surrealistic, because the fishnets are all pointing downwards. Okay, so the fishnets are more or less perpendicular to the plane of the galaxy. That's already surrealistic. There's no reason for that. We haven't observed this, by the way, okay? But this is what they're saying essentially. If they're going to put mass, dark kilograms in that region, that's what we should be observing. We should be observing something like this, stars moving, around that dark matter depression, okay? That's what it should look like. And again, this is surrealistic, actually. Let me get back in here. So how do we explain irrational science, with the rope hypothesis. And again, you don't have to believe in this. I'm just saying, if we're going to explain what these guys observe up there, okay, and that is that galaxies do not fly apart. That's the main point. I mean, why doesn't a star, if a star is a discrete entity, okay, and why doesn't it just fly out of the galaxy? Even if I put dark kilograms, keep this in mind. I put a bunch of kilograms in there. Why doesn't it fly out? What is about a kilogram about mass? What is the mechanism? How does mass keep that star from flying out? Well, it's got to have a depression. And what these people are saying, that we have all these potholes, especially on the outside of the galaxy. I don't know why all that dark matter is out there, but it's on the outside of the galaxy, and it's pushing against space or space-time downwards compared to the plane of the galaxy. And the star should be rolling around, each one of those little potholes. What sense does that make? We have a surrealistic vision. And again, it's like I showed in the past with the Earth. Why doesn't the Earth fly out of the solar system? Well, they say, well, because the sun weighs the canvas, the fishnet of space-time downwards. Okay, so it creates this depression. That means that there's a wall of curved time, essentially, and Earth rolls around curved time. Is that a physical interpretation? Does that make any sense? And then the nutty guy tells you on top of this, well, you're not supposed to take it literally. It's just an analogy. An analogy of what? I mean, you just said it's like a roulette. Fine. I understand. And what that means is the Earth, the skin of the Earth, is in contact with warp time. And that's what's preventing it from flying out. And this is more or less the same. You have dark matter, dark kilograms pushing the space-time canvas downwards. All these stars should be rolling around that little, or be affected by it. It should be a very messy picture with all these potholes out there. Is that what's happening? So under the rope model, we have a physical model. Okay, we can explain very easily under the assumption of the rope hypothesis what's happening out there, which is known as the galaxy rotation problem. And the main thing we want to solve, I'm not going to go through the whole thing, but the main thing we have to solve is why don't stars fly out of a galaxy? If the galaxy is rotating and these stars are traveling at great speeds, like when you swing a ball around your head, okay? You swing a ball around your head, if you don't have that little, if that string breaks, if that elastic band or rubber band, whatever you got it at the end of, if that happens to break, that ball will fly out. Why does it fly out? Because there's a physical connection from the ball to your fingers. That's why. And this is the same thing. We take a web, spider's web, right? And we just place it on top of the galaxy and make the assumption that all stars, all atoms, in fact, are interconnected, physically interconnected. Now we can see why the stars on the outside don't fly out and why the carousel spins as a unit, as if it were all interconnected. We can understand it now because we can understand it physically. By saying that mass keeps the stars from flying out, you still don't have a mechanism. All you're saying, there's a lot of weight in that region for who knows what reason. We don't see that, whatever the 100 tons of weight that are over there, but that keeps the stars from flying out. And not only is that a problem, because now Michio says, oh, we have all this dark matter flying around us. Everywhere, wherever we breathe, we're breathing dark matter. Well, if we have this dark matter everywhere in the universe, it doesn't explain why the stars on the outside of a galaxy don't fly out, or why they travel faster than those on the inside. So we better not have dark matter uniformly throughout the universe, because you haven't explained anything yet. I mean, if I were to sprinkle a little bit of dark matter, very extremely heavy dark matter, particles that weigh tons and tons and tons, if I happen to sprinkle that between the Earth and the Moon, neither Newton's equation nor Einstein's equations work. Gravitational equation. They wouldn't work. You can't sprinkle this stuff at random wherever you need and say, well, I'm going to sprinkle it over here to explain this, and I'm going to sprinkle it over there to explain that. You can't just say that it's everywhere, because if it's everywhere, it's nowhere. You can't explain with that the differences of speed if it's everywhere. No, dark matter was created for the stars on the outside of a galaxy. And of course, we can't see it. They say because their telescopes are not good enough. Okay, fine. They have job security looking for that stuff, right? And meanwhile, these guys get away with telling you, oh, by the way, it's everywhere. It's even here on Earth. All this dark matter. We're going to detect it with a Large Hadron Collider over there in Switzerland. Well, yeah, it's up to you to believe all this stuff or not. Okay, let's get back to Michio. What's he into? Well, he's into mind. He's into mind control. He's into artificial intelligence. He's into a lot of stuff that he would say, well, what's all this got to do with physics? Well, good old Michio, again, a caricature of science, of physics. Love the guy because he's just a comedian. That as long as you take him as a comedian, is no problem. He's good entertainment. Physics, that's something else. But he says, what do physicists do? Oh, what does a physicist do? Okay, he says, well, we invented the transistor, we invented the laser, we helped to assemble the first computer and the internet, we wrote the World Wide Web, and along the way we also invented television. We invented radio, radar, microwave, and we also helped to create the space program and the GPS system. And we physicists love to make predictions. Is this what physics is about? My God. Let's look up the word physics to find out if he's even in the ballpark, okay? And here's a definition, okay? You'll find it out there. A couple of them. Wikipedia says, physics, knowledge of nature, is the natural science that studies matter, its motion and behavior through space and time, and that studies the related entities of energy and force. Its main goal is to understand how the universe behaves. I don't see where it says anything about inventions. Do you? About developing technology, which is what good old Michio just talked about. Basic knowledge, another important site. Physics is the science of matter and energy and their interactions and motion through space and time. Again, no mention of inventions. Physics.org, the Institute of Physics. I mean, these guys, if they don't know what physics is, well, nobody does, right? The study of matter and energy and the interaction between them. But what that really means is that physics is about asking fundamental questions and trying to answer them by observing and experimenting. So we don't have any idea today what physics is about. These guys don't know. They've never defined physics. And by the way, physics has changed over the centuries. The notion of physics, science, the notion we have of science today comes from the 19th century. Before then, they had, natural philosophy, which is what they used to use all the way since Aristotle. And they had to change all that. They said, no, we do experiments. We do experiments and calculations. That's physics and that's science. So they changed it. And why? Because the mathematicians were in charge of doing what is known as physics and science. And so they took it along that course, not because that was its natural position. And what happens today, we don't have any of these explanations for natural phenomena. Why? Because all we have is descriptions and calculations, which are, again, descriptions and experiments. And what can you experiment with? I mean, gravity is invisible. Magnetism is invisible. We've done all the experiments we need to do. We know that a magnet attracts another. We know that you let go of the pen, it falls to the ground. We're done. We've done all the experiments we need to do. There's no other experiment that you need to do for gravity or for magnetism, for example. Okay, electricity, etc. So now we need to explain. We need to explain why the pen falls to the floor. That's all we need to explain. And they're saying it's not even in the job description of a scientist or a physicist. All they have to do is describe it. And in fact, here you have it. This good old man here. Let's see if I can get him up here. Got so many of these today. Okay, and he's Donald Simonek. He's from a professor, one of the universities there in Pennsylvania. He says, science doesn't explain, science describes. Okay, science doesn't explain, science describes. Why? He had to say that because that's what mathemagicians do. They describe. What is an equation? Equation is a description, especially of motion. And so they say, well, yeah, we can describe. We can tell you how fast the moon is going, how fast the lion travels. We know how much this weighs. We know how long this other thing is. And we can make a prediction if the car is traveling at 50 miles per hour in 1 hour, it'll be 50 miles away. So they can make a prediction. So that's all we have, descriptions. And then the next thing they introduce is technology. They say, oh, we can develop technology with all this. And so far, we have no understanding of what used to be called natural philosophy, which is, how does the universe work? I need to know how gravity functions, how Mother Nature does that magic trick. I need to know how a magnet attracts another. I need to know what electricity is. Okay, I need to know how an atom works. You know, and we don't have explanations for this type of phenomenon, which is, in all cases, it's the invisible phenomenon. Why? We don't have an explanation, or mathematicians don't have an explanation, because it's not in their job description. They think like Michio here, that, you know, physics is about developing gadgets and so on. That's the idea they have. That's the idea that they pass on to the public. This is why he's a communicator, a popularizer of what he calls science. And that's what people receive, and they regurgitate. They say, well, yeah, see, all these mathematicians, they say that science is, or physics is, developing gadgets and describing mathematically. And they just repeat this. And then everybody goes into Quora, and they say, well, how does a magnet work? And nobody can answer that question. Because immediately they start putting equations and say, well, here's the equation. And if you want to understand it, you got to go to college. Take a bunch of math courses. You know, I went to college, I took a lot of math courses, and I still never figured out, you know, how a magnet attracts another, how gravity works. I had to figure that out on my own. Okay, here's another aspect of good old Michio. Okay, again, a caricature of science and physics. Someday we'll be able to create a disk that contains every single neuron. He actually said this, okay? Contains every single neuron, all your memories, your desires, your hopes, dreams, encoded in a connectome. Okay, let me show you what a connectome is first. If I can get it here, it's so far down the list. Okay, essentially it's a map of the neurons in your brain. It looks something like that. Kind of pretty, right? It's making a map of all your neurological connections, okay, essentially, okay? And he says, okay, we'll be able to map that perfectly, okay? And he says further, he says, and if you have your genome and your connectome on two disks and you put them together, then you may even have a form of immortality. Now we're getting to immortality, you know, some of these people talk about uploading your mind to the internet. That's more or less where he's going with all this. All these people believe in the same nonsense. People like Ray Kurzweil and Bostrom and Max Tegmark, his buddy from Sweden, and Michio Kaku. So it says, this raises theological, ethical, religious questions. Who are you anyway? If you die but your genome survives and we can revive your body anytime, if we can bring back your consciousness, we're bringing back your consciousness at any time, then did you really die? We have immortality. We're going back to the days of the Dark Ages, you know. We have immortality. We're talking about, you know, going to heaven, internet heaven. This raises all sorts of questions about who are we? Are we nothing but information? My dear God, we're information. That's all you are. You're a bit of information. That's all you are, okay? And here's another aspect of how he's going into mind, how they're using all this. All these celebrities, they're going into the world of the mind. They're trying to tell you, you know, they're done with physics. They couldn't explain anything in there. So now they're talking about the mind, of how you think, of why you think the way you think. And they're bringing quantum and string theory to prove their point. They say, oh, it's been proven, so you got to accept it. He says, one day, perhaps your great-great-great-great-great-grandkids, right, will go to a library of souls, heaven, library of souls, and have a conversation with you. He actually said this because your memories, your personalities, or your quirks are all encoded in a hologram that you can bring to life by simply pushing the play button. So he's going to talk to his, or I guess his grandchildren are going to talk to him, and he's going to be alive because they got his consciousness, they got his genome, they got his connectome, they got all the stuff that they need, his essence, right? They don't need his body. His body died, was buried, or maybe cremated, who cares, you know? But they've got his soul, okay? And he rubs that in. He says, he actually says all these things. It just blows my mind that somebody would think like that today, you know, especially a guy who supposedly is educated, right? He says, can the mind exist outside the body? Mind, body? I think this is an old question, right? Said it was Descartes who said, I think, therefore I am, okay? And yeah, Descartes didn't know what the word exist means. That's why he got it wrong. He thought that he existed because he thought, or he thunk. No, you exist by definition if you are an object and you have location within our universe, in other words, within other matter in our universe. The mind is different from the body. It's called dualism. Recently, however, people say that that's a bunch of nonsense, okay? The mind is nothing but software running on waterware called the brain. That's all it is. It's one and the same thing. But now we realize they could be different. This goes back all the way to the Middle Ages. We may have the ability to place your consciousness on a connectome and send it into outer space. So they're going to send your not your brain, they're going to send your mind, your spirit, your soul. They're going to send that into outer space. Heaven somewhere? I don't know. I mean, your soul will be traveling through space. Okay? So if you have always wanted to travel through space, hey, these guys can do it. Okay, they show you how to do it. We're gonna transport your essence to the stars. Okay. Okay, and what else does Mr. Michio say? Well, he talks about telekinesis, and so he says, well, physics, you cannot read the mind. I assume he's referring to the fact that you need a physical object. Is that what he's referring to? Like saying you need some kind of uninterrupted physical connection in order to read the mind. Maybe at least that's how I understood it. There is another interpretation, which is, you know, you need the physicist to tell you something about the mind. So it depends on how you analyze this, okay? In the future, we will control things mentally. And there he destroys the first notion, because what he's suggesting here is that you can move things around with your brain only by thinking. You know, I can do that in my dreams. All the stuff, I can move around any way I want. Even when I fall from a cliff and never hurt myself, etc., you know. I do miracles with my dreams. But to say that while I'm awake and not under drugs or alcohol or anything, sound mind, that I can move a box, which is what he's saying here, that I can control things mentally, like move them around, okay? I don't know about that, okay? Now you got to explain to me what the mechanism is. How are you doing this? Okay? Tell me the magic trick. Okay? Stephen Hawking is connected to a laptop computer. Here's how it works. Sometimes we take a chip and put it right on top of the brain. The chip goes right on top of the motor cortex, right? It is then connected to a laptop computer that understands the impulses. Impulses. Well, what are these impulses? Are they little balls that come to the computer? I mean, we're sending signals, right? And we're sending signals through something we call electricity, magnetism, light. Take your pick. Something is going from A to B. And I said something. So it's not like with the mind you're going to control something, because what's going from the mind to the box that you're lifting? That's what you got to explain. And if you don't put something between that space, right, between your mind or your brain and the box, then you're by default putting spirits in there. You're using black magic. You're saying, I can move a box with my mind, and there's no connection there. No. Hopefully it's mediated by light, electricity, or magnetism. And so the question is whether any of those three are mediated by physical objects, or they're abstract concepts that are fit in there, which again is putting black magic, spirits, etc. You better put a physical object if you want to understand it mechanically. Otherwise, it doesn't happen. But he's getting away by saying impulses. He uses this word, and impulses is a concept. I can't say that I hit the box with impulses. No, you got to identify the physical object. So you got to be careful with the language, okay? For example, if you move your hand to the right, the chip registers the electrical impulses. So what are these electrical impulses? Are they just concepts that are moving through space? Is that what's moving the box or whatever you're going to move? Okay. Electrical impulses of moving your hand to the right, and it knows to move the cursor on the screen to the right. You have a dictionary of motions, and then by mentally thinking, moving your hand to the right, the cursor will move to the right. Yeah, but you got to do it with electricity, whatever electricity is, and hopefully electricity is mediated by a continuous. If you talk about flow, you're not talking about continuity, because even a river that flows is made out of molecules, and each molecule, unless it's connected to the other molecule, there is a separation. In other words, each molecule is independent, unless you can connect the dots, all of them. Then you can say, well, the river I can pull on a mountain. Otherwise, you can't. And maybe you can't because you can take a glass of water from the river and you can pull it right out. So apparently, they're not all connected. It's all these loose molecules. Okay. They're running down the river, and you can't pull with a river. And so if electricity is a flow of whatever, flow of electrons, flow of, I'll even concede atoms, ions, whatever you want to put in there, I don't care. But if it's a flow of discrete whatevers, then we have a problem because it's interrupted, okay? There's an interruption from molecule to molecule, from electron to electron, whatever you put in there, I don't care what it is, atom to atom, right? Ion to ion. Usually they do it with electrons, so let's use electrons. If every electron is discrete and just moving through space, then you can't do this because it should be a blip. There should be a blip in a space, a blip in a space, a blip in a space, like Morse code. Did it, da da, did it, da da, did it, da da. Okay, it should be like that. So no, you can't explain this with a non-entity, first of all, and it better be a continuous entity. There should be a physical connection from A to B, all the way from one place to another. Again, another suggestion that electricity is a serpentine, the merged shells. Then you can explain electricity. Otherwise, you have interruptions in the line. One of the problems with the electric universe, for example, is that they're using Bohr's planetary model of the atom. And so they talk about negative and positive. And so you have a proton ball, right? And you have the electron bead. And so what is electricity? Well, they say it's a flow of current. In other words, flow of electron beads from one atom to another. So when it's jumping from one atom to another, right, we don't have a connection. We don't, see, they say that all these stars and galaxies and gravity is done by electricity. In other words, the pull of gravity. And they say, yeah, because see, the one body is negative and the other one's positive, and so you have electricity, and it holds them together. Well, you can't do that if the electron is a discrete bead jumping from discrete atom to discrete atom. You can't do that with so-called plasma. You see the problem? So you can't explain electricity, assuming, you forget about the polarity and all that. You can't explain it because the atom that they're using is discrete. And the electron that they're using is discrete. And so that you can't have these jumping little beads from one atom to another and explain pull with that. That's the issue. Okay. And let's get Mr. Michio Kaku's final, like his closing arguments, like how he introduces string theory to justify, all this stuff. Let's put it. No, wrong one. I got the wrong one here again. Let me get this one here. Where is it? Here. He says, what are they looking for, with all this mental thing and quantum, etc., and especially string theory? What they're looking for is a one equation that explains it all, right? So we want to find the God equation, the ultimate theory that explains the entire universe. We want an equation that's maybe 1 inch long, okay, that would allow us to read the mind of God. We think we have it. It's called string theory. It's not in its final form and it's not testable yet. It's very hard to test. Personally, I feel no need to prove the theory experimentally since I believe it can be proven using pure mathematics. So now we have these mathematicians and they're going so abstract that now they're not even going to do experiments. Okay, and that's one of the criticism against string theory, that they're shunning, experiments to prove their theories, and they still want to call it physics, and they still want to call it science. So, again, what did he just mention? The fact that they were developing gadgets, and that's what physicists do. And now he's saying, well, we don't even need gadgets, and we don't need to do experiments. Oh, we're just going to do this with pure mathematics. But we physicists are optimistic. We think we will be able to test the theory, and we think it is the final theory. Now listen to this. It's the final theory, right? So physics ends at that point. Physics ends at that point. Another era opens up, but one era ends when we finally prove this is the theory of everything. So if physics ends and this era ends, what is it that what era begins? One era ends and the other one begins? One opens up? What is he talking about? I mean, what era? If it's the end of physics, it's the end of physics. So these guys just say whatever nonsense comes to their tiny brains and they just blurt it out there and everybody says, oh yeah, one era stops and the other one begins. I mean, if we figured out everything with this last equation, this final equation, there is nothing left, right? So what is that opens up? I have no idea. If string theory is correct, it means that all the subatomic particles, the electrons, the protons, are nothing but musical notes on a tiny vibrating rubber band, so that physics is nothing but the harmonics of the vibrating rubber bands. The universe is a symphony of strings, and the mind of God is cosmic music, resonated through hyperspace. I'm sure a lot of religious people love Michio Kaku, the physicist, the scientist. I'm sure the Templeton Foundation, which is trying to merge science with religion, they're absolutely happy with all these guys because on the one hand, these guys are conceding, oh, we don't know. Only God knows. God only knows, no one knows God's ways, that sort of thing, right? So they're repeating what the religious people have been telling them for eons, right, on the one hand. And then on the other, these people are saying, yeah, we do everything with magic. Well, that's how God used to do things, right? He did everything with magic. He would send a spirit, an angel, or whatever, and he would do all this magic, bring the souls to life. And so what is the difference between quantum mechanics, string theory, this idiocy that's trying to unite general relativity with quantum mechanics, so-called string theory, and all they're doing is saying that particles are vibration of these 1D strings that nobody can see. 1D string, can you ever see a 1D string? Well, maybe if you have a 1D eye, a 1D eye, you can see a 1D string. Yeah, no wonder we can't see them. If they're 1D, you'll never see them. And so what are these people talking about? They're talking about religion. All they did is repackage religion, the old-time religion. They packaged it under the guise of science. That's all they've done in physics. Anyways, with that, I'll see you next time. And hopefully my back improves. And keep sending the recommendations. I do recommend that you sleep facing downwards because with this problem, it's very hard to turn in bed first. And second, it's very hard to get out of bed in the morning because you're cold. You're until you move the skeleton, you can't turn. And on the other hand, if you're face down, not only can you turn better, you can switch sides, but you can also get out of bed a lot easier. You just let your legs drop without making any effort in the back of your back. And now I'm doing a little gym, and I think I'll get better. If I don't have a pinched nerve of some kind, or a nerve stuck between my two vertebrae or something like that, then I'll probably need something else. But if it's just muscular, it'll probably go away with a little exercise and good beer. We'll see. We'll see you on Sunday. Bye-bye.